Good morning, Sir Safwan. Here is our group e-learning 3, and our group member has Kelvin, Chu, and Eugene. Our group today is to share a method that build on what students already know in to solve a common math problem. So we are going to transform a confusing rule into a clear understandable process uh, and the topic is why is decimal division so tricky. So the division is not it's not the problem. This is the decimal points in a problem like uh 12.75 divide by 0.5. Students are completed stuck on where to put the decimal. So this confusion will lead to major error. They either ignore the decimal and divide the question, or they get the right number but the wrong placement, like 2.55 instead of 25.5. So students usually uh when do the division the decimal division, there has many mistake. Like the first one is ignoring decimal. So like with this 1275 divide 5. So the second is the misplaying decimal, and the third is the root cause, like the procedural teaching without understanding the uh, decimal division. So the student just move the decimal, but they don't know why why we just move the decimal.
And now we are going to talking about the core idea is about the transform the problem. The big idea is to turn it into a problem you can already solve. Okay, we know that 12 divided by 4 is the same as the fraction 12 over 4. Therefore, 12.75 divide 0.5 is the same as 12.75 over 0.5. So the concept here is to convert the decimal division problem into an equivalent whole number division problem. The method is used on the mathematical principle of equivalent fraction. So the magic rule here is that we can multiply the numerator and the denominator by the same number, a power of 10, without changing the value of the fraction. So look at the step 12.75 divide 0.5. So this fraction we multiply 10 over 10. So it will become the 127.5 over 5. So the result we get is the new problem. The 127.5 divided 5 is much easier to solve because the divisor is now a whole number. My proposed teaching method is all about transformation. Instead of giving students a new compressed rule, we connect it to something they already know. Fraction and whole number division. The key is to show them that we can change the problem into an easier, equivalent one. By multiplying both parts by 10, we are essentially just multiplying by 1, which doesn't change the answer. This turns a tricky decimal problem into a familiar long division problem. Now it's about the step-by-step method, which is shift and solve. The example problem is that 4.2 divide 0.225. So we can write the problem as fraction 4.2 over 0.25. So we can focus on the divisor 0.25. How many decimal place does it have? The answer is 2. So to make it a whole number, we need to multiply by 100. Shift the decimal 2 place to the right. So do the same to the dividend 4.2. So look at the step 4.2 multiplied by 100 over 0.25 of multiplied by 100. The answer we'll get is 420 over the 25. So now perform the standard long division for 420 divide 25. The answer is 16.8. So let us walk through my shift and soft method. First, frank as a fraction. So second, shift the decimal. Look at the divisor 0.25 is need to shift to become 25. That means we multiply by 100. To keep it fair, we must also multiply the third number 4.2 by 100, which gives us a 420. Now our final step is to solve the new problem. So 420 divided by 25 is a standard long division problem students are comfortable with. So this is a summary for the step-by-step method, which is the shift and solve.
All right, so we've just seen how Shiv and solve method works step by step. Right. Okay. So wait, what is it? Okay. Okay. So now we're gonna see why this method works. Okay. So we could say that as educators, right? Okay, we just now have seen how the Shiv and solve method works step by step, but it's so important for us because it doesn't show just how, we also need to show why. Okay, so why is this method approach so effective for our students that we see? All right, so first come first is actually building this confidence and also conceptual understanding about students. Okay, so this concept, this method actually connects directly to what the student already know, since we are not asking them to learn like something we could say like totally new or isolate skill, but instead we are just building a bridge from two concepts that have spans years on. Okay, so the knowledge is actually of equivalent fractions and their comfort with regular long divisions. So, the skill students already have about this fraction multiplication and also whole number divisions. Okay, so we continue with the second one. Second is reduce connective loss. Okay, reduce the connective loss of students. So the traditional methods often feels like a list of random rules, just like, for example, count the space here and move the decimal there. Okay, so this is actually what dialogue happens in the class when the teacher is teaching, and then they will say that remember to bring it here or bring it there, okay, bring it up. Okay, so actually it's a lot of joggles, and because this method simplify all of that down into one single and clear mission at the start. So this method, I would say that they can make the divisor become a whole number. So once they have done that, one thing, okay, the rest of the problem is familiar theory. So it free up their mental energy to focus on the division itself. Okay, just focus on the division. So just make a division or divisor a whole number. All right, so we continue about the addresses, the why. Okay, this is the most critical part. I would say that because it's actually answer the why behind the procedure. Okay, it replaces what magic tricks that we have learned with mathematical logic, and the best way to illustrate this is with a real world analogy that students is instantly they can get, which is, I would say that money. Okay, so let's take a look. Is it provides a logical reason for moving the decimal point rather than just procedural rules as not by signed from 2004. Understanding place value is critical, and this method uh, ex- explicit explicitly show the effect of multiplying by power of 10. All right, so this is about the visual analogy. So let's think about these problems. Okay, uh, how many? Okay, I like asking, right? How many quarters, which is RM 0.25, are in 4 ringgit and 20 cent. Okay, how many 25% is in are in the 4 ringgit and 20 cent? So it's actually same with how many groups of 25 cents are in 420 cents. Because it is exactly what the shift and soft method does on paper. It takes and I would say that abstract decimal problems and also make it a concrete whole number problems. So it proved the student that the uh how is that that the okay it's prove the student that okay the rules of maths okay are not arbitrary and they can just based on logical and also our real world real ideas that already understand how to solve the problems. All right. So before we going with the takeaway, I will say that by using the approach, okay, we are not just teaching. You could say we're not just teaching a procedure to get the right answer. We are actually building their confidence and a deep conceptual understanding that will stick them with for years to come. Okay, with mathematics. So now we're gonna look for uh key takeaways. About a key, I will say that to teach decimal division effectively, transform the problem into one student already know how to solve. And this is build confidence, reduce errors, and fostering true mathematical understanding. So right, now we show that the reference that we have for this presentations of our informations. So come on, let's make a short conclusions. So in conclusion, we will say that by focusing on transformation rather than just rules, okay, we can demystify and the decimal divisions. So other than that, we can also empower students by connecting new challenge to their existing skills. And I think that's all for our short conclusions. All right, so that's all for our presentation. Thank you for listening and goodbye.